So, populations and carrying capacity. What kind of things can impact the size of a population? What kind of things can impact the size of a population?
Marriages.
Sorry?
Marriages.
I can't hear you. What?
Marriages.
Marriages? I mean, extrapolate that a little bit. What would a union of a male and a female result in? Reproduction, babies, right? So yeah, babies, right? We can have babies, which will increase population. What'll decrease population?
Divorces.
Well, divorces aren't going to decrease your population. You gotta be way more morbid than that. Yeah, Yubo?
Wars.
What happens in wars? Yeah, people die. So death is a way population can decrease. What's another way population could increase? Hint, in Winnipeg, we do a lot of it here. In fact, the only reason why in Canada our population doesn't actually decrease every year is because of this.
Less abortion.
Less abortions? No. No. That's a good guess though, Lena.
Old people live longer.
Old people live longer. Also pretty good guess. Yubo? Not food. What do we bring a lot of into Winnipeg? We bring in a lot of what?
Immigrants.
There we go, Shifa. Excellent. Immigrants, right? Immigration is another way to increase your population. What is another way we could decrease our population, which might be happening in the States in the next week or two? Maybe people are going to run to Canada. Do you know what we call that when people leave a country? Or leave an area? It's emigration. Emigration. So those are the different ways populations will change in an area. For most of human history, what were we? For most of human history, what were we? Go back 100,000 years ago, how were we gathering our food?
Hunting.
We were hunters and gatherers, right? We were hunters and gatherers. So, yeah, it's not going to work. We were hunters and gatherers. Now, what changed about 12,000 years ago? Sorry?
Farming.
Excellent. Yeah, Lena. Excellent. We became farmers. Now, where did farming develop in the world? Does anyone know? Oh, you're good, Addy. Ancient Mesopotamia is where our first evidence of agriculture pretty much is. Now, that changed the game big time. Because now we had the ability to create a lot of food, a ton of calories, and only a couple people had to do that. So this allowed people to specialize, right? And we had to protect this food from other animals and other hominid species, right? From other humans as well. So we started to develop civilizations, develop cities. Really, farming was this big driving force in the explosion of the human population. Because before this, we were existing somewhat sustainably with nature. Our population was not changing by a ton. Really, our population started to explode when we became farmers. Now, how much did our population explode? Well, if you go look at like the mid-1600s, the human population was about 500 million. Now, what is it today? I don't have a very updated number here. Does anyone know what it is today?
9.8 billion.
It's not that high. It's like 7.8-ish, I want to say right now, 7.9, something like that, billion people. Does anybody know where our population is going to plateau? Will it plateau? What do you think? Well, there's going to be a video I'm going to post on my website. I highly recommend you watch it. It's going to be on demographic transitions and why our population is probably going to plateau at about 11 billion people on Earth. Now, what are the things that affect population? We've already talked about it. The fancy word for making babies is natality. And This is simply just the birth rate. And if we look at this graph here, you'll notice that per couple, per 2 people, what is the birth rate in Canada? Is it less than 2? This right here is 2, and this is Canada's birth rate. Is it less than that? Yeah. So what does that mean? If we didn't have immigrants coming into our country, what would be happening to our population?
Decreasing.
It would be decreasing, right? Because we're not having enough babies to sustain our population. Anyone here ever been to Japan? No? They are very, very, very strict about who can live in Japan. You pretty much need to marry a native Japanese citizen in order to have permanent residency there. In saying that, they have a very, very, very old population. I forgot exactly when it was, but not too long ago, Japan was the first country in the world in which adult diapers outsold children's diapers. So they have an aging population. Their population is decreasing, and it's going to be an interesting social experiment to see what happens. Some cool side effects, because there's more houses than there are necessary, there's huge supply. Lots of houses there are like dirt cheap to buy if you're outside of any city center. Almost free, in fact. So there are some cool benefits, but there also is potential downsides. Economists are looking very carefully to see how their economy is affected by this. Now, we bring in immigrants though, so our population is still going up in Canada. In fact, in Manitoba, we bring in the most immigrants per capita in all of Canada. Does anybody know, where's the main places we bring in immigrants from? For the past 20 years, it's been, well, probably longer than that. It's mainly been from these places. Where would you guess?
Syria.
Nope, not Syria. I mean, we did bring in a bunch of Syrians, but not even close to the largest percentage of immigrants we bring in. So if you lived in the North End, you would know the answer instantly. Anyone here ever go to Sisler for sports? Yeah, there you go. If you've been to Sicily, you know what I'm talking about. Filipinos are one of the largest ethnic demographics we do bring into this province, and the other one is effectively Indian subcontinent. So India and the surrounding areas, but mainly India, would be the 2 largest populations we're bringing into Winnipeg right now. But yeah, we are the immigration capita of Canada, which is kind of cool. Now, how do things leave a population? How does the population decrease? Well, one of those is going to be mortality. So when things die. Now this is one of the happy graphs I get to show you, because usually my statistics are very depressing. This is a really, really happy one. This is a graph of infant mortality, so babies dying. What do we notice about babies dying? What's happening?
Decreasing.
It's decreasing, and this is in Canada. So our infant mortality rate is extremely low, but around the world right now, our infant mortality rate is going down, which is super, super awesome. Everywhere in the world right now, if you look at the average infant mortality rate, it is going down. Now, as less babies die, what happens to the population? What do you think?
Grow.
Yeah, it grows, right? So many parts of the world, back in the day, why did you have like 17, 18 babies? That's it. That's crazy. No, why did you have like 7, 8 kids back in the day?
No protection.
That's not exactly why.
Some of them could die.
Yeah, it's really morbid reason why. It's because most of your kids would actually die if you go back a couple hundred years ago. So they had a lot of kids because not many of them would survive to adulthood. So usually what happens is, like in Canada, for example, medicine improved, infant mortality rates went down, our population exploded, then people stopped having less babies. And that seems to be the rule around the world. We find as countries become developed, once infant mortality drops to a low enough number, there's this population explosion because people are still having tons of kids, and then they just stop having as many babies. And this is happening all around the world, which is why we predict population will plateau. Now, emigration is the other way in which a population can decrease if members leave that area. And again, who knows, maybe we're going to see a massive spike. Maybe there's going to be civil war in the States, I hope not, and we'll have a bunch of, someone in my other class this morning suggested, maybe we're going to have a bunch of US refugees come to Canada. I really hope not. But there was actually a little spike in emigration from the US when Donald Trump was elected. People actually legitimately backed up their claims of wanting to leave the US. It wasn't much, right? But people actually did come to the US, come from the US to Canada. In fact, our immigration website crashed after Donald Trump was elected. Now, population growth is the combination of all of these factors, right? So it's going to be births plus immigration minus deaths and emigration. That'll tell you if your population is going up or going down. Okay, so those are the factors that decrease population, but what limits your population size? Because there's certain organisms out there, like the mouse, for example, if you give them all of the resources and space they need, well, we're going to be overrun with mice. So as an example, they only take 6 months to reach sexual maturity, at which point they can have a litter of pups every 6 weeks, and that litter of pups can be 6 or more mice. So within, if we had 20 mice and we let them reproduce uncontrollably, in half a year you would have over 5,000 mice. Why doesn't this happen? Sure, predators, excellent. Why else? Why doesn't this normally happen in nature?
Limited food.
Sure, food, right? They don't have enough access to resources. What else? Why are you all wearing masks right now?
Viruses.
Disease, right? If there's a bunch of members in close proximity, disease will kill them off. What else? That's okay, we're going to talk about a lot of different reasons why right now. So, before we jump into those reasons why, let's talk about how organisms have different strategies for reproduction. So, biotic potential is the maximum number of offspring that a species could produce if resources were unlimited. And this is the maximum number that reach adulthood. So, the 4 factors are birth potential, capacity for survival, procreation, and length of reproductive life. Looking at all of these factors individually, it should just be common sense to most of you, right? Birth potential is the maximum number of offspring per birth. What is our birth potential? Humans. How many offspring do we have per birth? Normally, 1, right? It'd be like 1.01 or something, because some percentage is twins and triplets and whatever else, right? But generally 1. How about like a crab? Or like a mosquito? How many eggs will they lay? 10, a lot more than 10. Depending on the species, hundreds if not thousands, right? So, very different life strategy. Alright, so capacity for survival. This is where we differ a lot from crabs. This is the number of offspring that reach reproductive age. In general, do our offspring reach reproductive age? Yeah, infant mortality is super low now in Canada. Generally, our 1 offspring reaches reproductive age. How about for crabs? What percentage of those thousands of eggs do you think reach reproductive age? Yeah, probably less than that even, right? Probably less than 1%. A very small percentage would reach reproductive age. All right, What about procreation? The number of times that a species reproduces each year. What is that number for us?
One.
Yeah, probably slightly less than 1. I mean, if you and your sister or brother are like 1 year apart, holy smokes, that is close in age. That is like the closest you can pretty much be. But yeah, about 1-ish. Now, what is it for mice?
2 weeks.
It was every 6 weeks they could reproduce again, right? So it'd be a much higher number. So last factor is length of reproductive life. Now, the longest reproductive lives out there are the large mammals, right? Like big whales, elephants. And elephants, their reproductive life is from 15 years of age to about 90. These are African elephants. So there's a huge reproductive life. Whereas other organisms, for example, let's say, I don't know, you are a mosquito. How long is your reproductive life?
Weeks.
Yeah, literally, like it's, they only reproduce once in their lifespan, but they are only adults, mature adults, for a couple weeks, if that, before they lay their eggs and die. Right? So different organisms have different strategies, is all I'm trying to get across here. Okay, so those are the things that are going to affect biotic potential, but there's also environmental factors. For example, a fern produces 50,000-ish spores in a year, and if all of these spores germinated, we'd be covering all of North America in a couple generations of fern. But all of North America isn't covered in ferns. Why not? Why not? Sure. Maybe those spores end up in a more arid climate where they don't have the right conditions to grow. What else?
Land.
Sure, maybe they end up in the water or someplace that is unsuitable. Maybe they don't have the space. What else? Are there other plants out there? Yeah, right. So what are those other plants going to do? Are those other plants competing for space and water and light resources? They are, right? So there's a lot of other factors that are going to go into what is the population limit within an ecosystem. So, what are the factors that limit the population size? Well, there's a series of abiotic and biotic factors. Your abiotic are going to be things like light, water, the chemical environment, is there enough nutrients, temperature, things like that. The biotic factors are going to be things like access to food, the number of predators. Is there diseases that are going through that population? You know, am I able to compete for resources? So there are a series of abiotic and biotic factors that are going to control where that population is at within an ecosystem. Now, those factors combine into something that's called the carrying capacity of an ecosystem. This is an important term. So this is the maximum number of organisms that can exist in that ecosystem of a particular species. So the carrying capacity is determined by all of these different factors. So, you know, what are the biotic and abiotic components of your ecosystem? How do they interact? And as a result, what is going to be that carrying capacity? Now, it's important to note that your carrying capacity is not static, right? I'm not going to say the carrying capacity of our ecosystem is 1,000 deer, therefore we always have 1,000 deer. That would be crazy. Why is that crazy? Why is it here that if this is our population of deer, for example, why is it fluctuating around our carrying capacity? Why is that happening? Is nature constant all the time? No. No, we've had a fairly good winter, which means likely populations of many animals, like deer for example, are probably going to be on the rise. But what happens when you have a really harsh winter that's super cold and long? Do you think their populations could go down? Yeah, right, a lot of their populations could go down. There isn't as much production in the winter, which makes it harder for many organisms to survive. Or even say, maybe it was a really good year and the wolf population exploded. Well, if we have a lot of wolves, what's going to happen to our population of deer? It's going to decrease. What happens to our wolf population when the deer population gets really low? It's going to decrease as well, right? So what happens, say, if a forest fire rolls through an area, like what happened in Australia or California? What's going to happen to our population of deer? It's probably going to decrease, right? Maybe it's a really plentiful year with a bountiful summer with lots of rain. What could happen with our populations then? Increase, right? There's a lot of factors, right? Nature isn't constant. There's a ton of factors that will cause this population to fluctuate about its carrying capacity, okay? And hopefully the assignment that you just got clarifies that, because it's going to force you to think about carrying capacity. Now, I'm not going to work through this example with you because I just used the one of deer, so in the interest of time we're going to skip this example. But that example I used with deer, you can apply that to pretty much any organism within an ecosystem. Lastly, I want to talk about density factors. When I say dense, like population is dense, what do I mean?
More population?
Not just more population, you're right, more population, is it in the same amount of space?
Overpopulation, smaller space?
Yeah, we're talking about a lot of individuals in a space, right? In a space. The more individuals you have in a given area, the more dense that population is. Now, how will that impact certain things? How, for example, will population density impact, say, if there's a disease rolling through the area? Do you think if the population's denser, it'll have more of an impact?
Decrease?
What would decrease?
Population?
Yeah, you're right. It would have a larger impact. It would decrease the population more. Now, if everyone's really spread out, like our social distancing here, what do you think would happen to the population? Would they be as affected by that disease? No. So that is something we would call a density-dependent factor, right? It depends upon how dense your population is in a given area. Now, a density-independent factor doesn't care. For example, do you think it matters how dense the population of koalas was, or how dense the population of kangaroos was when it came to the fires that rampaged through Australia?
Yeah.
Do you think it caused decreases in their populations no matter how dense they were?
Yeah.
Of course. Right? It doesn't matter how sparse or how dense the population was there in Australia. That massive forest fire killed a lot of organisms regardless of how dense those populations were. We call those things density-independent factors. So density-independent factors are going to be effectively natural disasters. Droughts, storms, tornadoes, hurricanes, forest fires, volcanoes, right? Those are going to be things that cause decreases in population regardless of how dense that population is. Right? They're going to affect that population regardless of how dense that population is. Now, when we talk about density-dependent factors, those are going to be things that rely upon how dense that population is, right? If we look at, for example, a predator-prey relationship. If I have a lot of prey, what's going to happen to my population of predators? It's going to increase. If I have not much prey at all, what's going to happen to my amount of predators? They're also going to decrease, right? These are density-dependent factors, right? Because the density, how many organisms you have in that area, will determine the magnitude of this effect. So, things like food, flood, fire, pesticides, temperature, change in climate, destruction of habitat, drought, those are density-independent factors. And then things like food shortages, competition for mates, breeding areas, diseases, introduction of exotic species, predation, and competition for resources, those are density-dependent factors. You do need to understand that distinction for your unit test, by the way. Alright, so that is it for today. Does anyone have any questions?